Good morning, children. So we have completed 9 chapters so far, and we have to start with the 10th chapter. And the good news is that this whole chapter is cut. Okay, I remember first I told you it's cut, then I told you it's not cut, but then finally now the final thing which has come from ICSC, they said that this chapter is completely cut. Okay, so you can put a big cross mark and we'll go to the 11th chapter. Okay, so this is supposed to be one of the complicated chapter, but yeah, anyway, so it's cancelled now, and so today I'm going to start with the 11th chapter, that is calorimetry. Okay, that is related to heat. Okay, so if you see, as I told you, we have the chapters have been grouped in first 3 chapters were related to force, work by energy. Then next 3 chapters related to light. Okay, then we had refraction through plane surface, then through lens, then through spectrum. Then we had sound. Under sound we had only 1 chapter, electricity and magnetism. There are 3, but 1 is cut, so you have only 2 chapters under that. Now under heat, again you have 1 chapter. Though it is a single chapter, its weightage is quite high. Like you get questions for like 14 to 15 marks from this chapter itself. Okay, so because because it's a 1 chapter under heat, its weightage is quite high. Okay, so each and everything is very important in this chapter. So let's start studying. Okay, so the first thing we are going to see is the concept of heat and temperature. You have seen this in 9th standard also, so we'll have a quick recap of heat and temperature. What is the difference between heat and temperature? Okay, maybe in normal terms, in the sense in our regular usage, they don't make much difference. Okay, it's very hot or temperature is very high, it seems to be the same, but according to physics they are two different quantities. Why? Heat is a form of energy. Heat is a form of energy that causes a sensation of hotness or coldness. So we know everything. We can define sound is a form of energy that causes sensation of hearing. Okay, heat is a form of energy that causes a sensation of hotness or coldness. Then light is a form of energy that causes sensation of vision. So like this, these are the forms of energy that causes a particular sensation. Okay, whereas temperature, when I say temperature, it tells me exactly how hot or cold the body is, or I can say it describes the degree of hotness or coldness of the body. Degree of hotness or coldness. If I say the temperature today is yesterday night the temperature was 4 degrees Celsius, then you know it was a very cold night. Okay, so or in summer, one day you say the temperature today in the daytime, like maximum temperature was 42 degrees Celsius, then you know it was a very hot day. Okay, so this tells us the degree of hotness or coldness, in the sense how hot or how cold a body is or the day is. Okay, unit, because it's a form of energy, its SI unit will be joule, and this can have degree Celsius or Fahrenheit or Kelvin, but the SI unit is Kelvin. SI unit is Kelvin. Okay, so then what is the, so unit, second point is the unit. Third point, what is the device that is used to measure heat energy? Usually calorimeter is one device, one apparatus that we used in lab to measure the heat energy, and you know temperature is measured in thermometer. Temperature is measured using a thermometer. Okay, so these are some of the basic differences between heat and temperature. Basically, it's a form of energy. Its unit is joule, measured using calorimeter. It expresses the degree of hotness or coldness. Exactly tells me how hot or how cold the body is. It says the unit is Kelvin, and device used to measure temperature is thermometer. Now, what happens whenever a hot body and a cold body are combined together? Now, suppose you had um, um, hot water in this vessel. Okay, this water was at say 75 degrees Celsius. Okay, now you poured some cold water into it. Okay, which is at say 20 degrees Celsius. You fill from the tap. Okay, maybe these days in the night time, if you fill from the tap, the temperature might be 20 degrees Celsius, and here there is a 75 degrees Celsius water already there. So now you poured it. So what happens? This hot body and the cold body are mixing together. Okay, they are mixing together, and what will happen? Hot body will give its cold uh, hot body will give its heat energy, and cold body will gain heat energy. Okay, hot body gives heat energy and cold body gains heat energy. It takes heat energy. Okay, now this will happen as long as, now what will happen, this water's temperature will keep going down because it's giving heat. It will become 70, 65, 60, like that. It keeps going down. And what happens to this cold water's temperature? It keeps increasing. 20, 20, from 20, 25, 20, 30, 35, 40. Now this exchange, so what is happening? Exchange of heat energy is happening. How long will this happen? Till both of them reached a equilibrium temperature, or we can say same temperature. This exchange of heat will take place as long as the entire thing reaches a equilibrium temperature. Equilibrium means same temperature. So this keeps decreasing from 75. This keeps increasing from 20 degrees Celsius, and then both will reach a common temperature. We don't know. Maybe everything together might reach a same temperature. That is maybe 45 degree. That's called the equilibrium temperature. Okay, so at that time this exchange of heat will stop. Till that time heat will be exchanging till the whole thing reaches a particular temperature, and that is called equilibrium temperature. So this is what happens when we mix a hot body and a cold body. Okay, so next we are going to see about okay, some units. Okay, we'll see from the book. You can open your book, turn to page 261. Okay, calorie was one of the unit that was used in earlier. So 1 calorie is the quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. Okay, 1 gram of water will be very less, like 1 ml. You'll have seen the measuring cup for medicine, 5 ml. Usually we drink 5 ml. That itself will be so less. So you can imagine 1 ml means very less, right? 1 gram. 1 ml will be nearly equal to 1 gram. So to heat that much water, to increase the temperature of that much water by 1 degree Celsius. When I say increase the temperature means, so raise the temperature of 1 gram of water through 1 degree Celsius means, suppose I fill that water from a tap and the temperature was say 20 degrees Celsius. So from 20 to rise the temperature to 21 degrees Celsius, okay, through 1 degree means by 1 degree Celsius. To raise it to 21 degrees Celsius, how much quantity of heat is given? That is 1 calorie. Okay, that was the unit that they used before. But later on, the other units, okay, like Okay, kilocalorie is a bigger unit, but then joule was the most, SI unit is joule. 1 calorie is 4.2 joules roughly. Okay, you have to remember this. 1 calorie is 4.2 joule. Kilocalorie will be 1 kilocalorie is 1000 calorie. Okay, now comes the concept of heat and temperature. Okay, so unit of temperature, Kelvin is the SI unit. You know how to convert Celsius to Kelvin. You have to add 273. I'm sure you have studied this in chemistry. So, okay, then, okay. Thus, a degree is the same on both Celsius and Kelvin scale. Okay, when I say change in temperature, that will be the same in Celsius and Kelvin scale. Okay, that we'll do later. Now, here is the difference between heat and temperature. Heat is a form of energy obtained due to random motion and attractive force. Temperature is quantity which determines the direction of flow. SI unit is joule. SI unit of temperature is Kelvin. Amount of heat energy depends on mass temperature. Okay, so you can just go through it. This is usually they don't ask this. This is all like revision of what you did in 9th standard. You had done all this in 9th standard. Okay, and the actual thing starts from here. Okay, so just go through it, just have an idea about difference between heat and temperature, and then what happens when a hot body and a cold body are combined together. This is what happens. Now let's start with the actual thing. First concept that we have to know is heat capacity. Heat capacity, HC. Okay, what is heat capacity? Now, I suppose imagine I filled water in a vessel. Okay, from the tap I filled water. Okay, I don't know how much. Okay, it can be 1.5 kg, 2 kg. I'm not worried about how much is the quantity, but I just fill the water. Okay, and so its temperature was say 25 degrees Celsius. Okay, tap water right now maybe 25 degrees Celsius. Now I started heating it. I placed this on top of a stove. So how did I know the temperature? I should have put a thermometer inside it and measured the temperature that showed 25. Now I started heating it, and I'm going to heat it till it reaches 26 degrees Celsius. From 25 it has to reach 26, in the sense it has to raise by 1 degree Celsius. So the amount of heat energy that was given to raise the temperature of this much amount of water by 1 degree Celsius is called heat capacity. Okay, so it need not be water, it can be any substance. It can be any substance. Now suppose you take um, a vessel or a metal block, maybe an iron block. Okay, and then we are going to heat it. Okay, and it was initially at say 25 degrees Celsius, and then I heated it till it became 26 degree Celsius. So to bring about this 1 degree rise in temperature, how much heat energy was given, that is called heat capacity of a substance. And every substance will have a different heat capacity. Water will have a particular heat capacity, and solid will have different solids will have different heat capacities. Okay, so the first topic that we are going to study is heat capacity. Okay, so the definition goes like this: heat capacity of a body is the amount of heat energy required to raise its temperature by 1 degree Celsius. Okay, that is the definition of heat capacity. Now, if I have to write it as a formula, heat capacity is usually represented by the symbol C dash. C dash, okay? Amount of heat energy supplied upon rise in temperature. That is the formula for heat capacity. Then, okay, so if this is in words, this is in a symbol. Okay, if Q is the amount of heat energy, And del T is the rise in temperature. You understand what is del? Change in temperature. Delta T, okay, change in temperature, rise in temperature. So that is del T. Then symbolically I can write C dash is equal to Q by del T. This was in words and this is in symbol. Now, unit of heat capacity. Okay, so it is heat energy upon temperature. So what will be the unit? Joule per degree Celsius or Kelvin. So SI unit is joule per Kelvin or joule per degree Celsius. Joule per Kelvin or joule per degree Celsius. Okay, both are, though Kelvin is the most appropriate. This is the SI unit, but most of the time degree Celsius also will be used. Okay, now we come to the next topic. Okay, what if I say heat capacity of a vessel is 30 joule per Kelvin? What do you mean by that? Okay, what do you mean by, okay, or um, what is the meaning of, or what do you mean by when I say the heat capacity of a vessel is 30 joule per kg? It means to raise the temperature of that vessel, we don't know what material, whatever was the material, to raise the temperature of the vessel by 1 Kelvin, 30 joule of heat energy was required. It means that, so what do you mean by heat capacity of a vessel is 30 joule per Kelvin? So heat capacity, they can either ask the definition directly, define heat capacity, or this is a kind of application question. They'll ask, what do you mean by the statement heat capacity of a vessel is 30 joule per Kelvin? So what will be your answer? It means that 30 joule of heat energy is required to raise the temperature of that vessel by 1 Kelvin or 1 degree Celsius. Okay, children, I remember I told you current rating, voltage rating, all that definition also can be asked. They can ask you as an application question also. I remember even refractive index was like that. Okay, so both the ways you should be able to write. Okay, the next topic is specific heat capacity. So heat capacity is amount of heat energy required to raise the temperature of a body, okay, by 1 degree Celsius. So upon rise in temperature, because it's very difficult to find for 1 degree. So usually what they do, they allow it to, because 1 degree Celsius change will be quick, so they allow it to heat till 50 degrees Celsius. Okay, then they will calculate maybe to heat to reach from 25 to 50. Suppose it took 100 joules, then I can calculate heat capacity by dividing 100. To increase by 25 degrees Celsius, 100 joule was used, but heat capacity means I need to increase by 1 degree Celsius, how much was used. So usually what they do is they rise it by a bigger amount and then they divide it. Okay, so the change in temperature was 50 minus 25, that is 4 joule per Kelvin. So the heat capacity of this particular substance is 4 joule per Kelvin. Is it clear? So unit joule per Kelvin or joule per degree Celsius. Okay, then comes the next term, specific heat capacity. Specific heat capacity. Now, what is the difference between heat capacity and specific heat capacity? When I said heat capacity, I said you need not worry about the mass. Okay, in the sense you could have taken 1 liter of water, 1.5 liter of water, 2 liter of water. Okay, when I say heat capacity, I don't consider the mass, in the sense it can be any mass. Okay, same way, to just heat this cube, I don't know its mass, by increase the temperature by 1 degree Celsius, whatever was the heat energy required, that was the heat capacity of this material. Okay, but when I say specific heat capacity, that means to increase the heat energy required to raise the temperature of a unit mass of a substance. Unit mass means if in SI it will be 1 kg, if in CGS it will be 1 gram, or to raise the temperature of 1 kg of this particular substance by 1 degree Celsius, how much heat energy was given? Okay, that is called specific heat capacity. Specific means specifically for this particular mass 1 kg ke liye how much heat energy it requires. Can you understand? So when I say heat capacity, it's for the total mass. I'm not worried about how much mass. It can be 1 kg, 2 kg, 3 kg. I need not worry about the mass. But when I say specific heat capacity, it's specifically for 1 kg of that substance. In SI, it is 1 kg. So we use the word unit mass. Unit mass means either it can be per kg or it can be for 1 gram, like that. Okay. So that leads me to, so the heat capacity is represented by C dash. Specific heat capacity is represented by symbol C. Okay, and amount of heat energy required to raise the temperature of a unit mass of a body. Okay, so if the mass of, suppose imagine this whole block's mass was 5 kg. Whole block's mass was 5 kg. So what I have to do, if heat capacity, okay, to increase the temperature of the whole mass, maybe it took, say, 150 joule. Okay, that is its heat capacity, joule per Kelvin. Now, if I have to find specific heat capacity, what should I do? This 150, I have to divide it by 5 kg. Because when I say specific heat capacity, I need for 1 kg. So I have to divide it by total mass. Okay, that will give me the amount of heat energy required to raise the temperature of 1 kg. So what we have to do in this formula, we have to, so mass upon rise in temperature, so is already there. Okay, or I can say specific heat capacity is heat capacity upon mass. Heat capacity, if I divide by the total mass, that will give me specific heat capacity. Or in terms of formula, if I have to write, because heat capacity is already amount of heat energy upon rise in temperature, here mass will also come to the denominator. Is it clear, children? So next, what will be the unit? So heat energy joule per mass kg and temperature degree Celsius or Kelvin. Joule per kg into Kelvin. These are the SI units. CGS unit, okay, joule per gram degree Celsius or joule per gram Kelvin. This is the unit of specific heat capacity. Now, what is the relationship between heat capacity and specific heat capacity? See, so I started off like this. Specific heat capacity is heat capacity upon mass, or I can write heat capacity is mass into specific heat capacity, either this way or that way. This is relationship between heat capacity and specific heat capacity. If they ask you relationship between heat capacity and specific heat capacity, I have to write this. So now every substance will have a particular specific heat capacity. Okay, every substance will have a particular specific heat capacity, and it's a standard one. In the sense, if it was iron, okay, if this solid was iron, to increase the temperature of 1 kg of iron by 1 degree Celsius, there will be a particular amount of heat energy, and that will be the same always. Same way, if it is water, okay, to increase the temperature of 1 kg of water by 1 degree Celsius, okay, and that amount of heat energy will always be constant, and it is 4200 joule. It seems to be quite high. Just imagine, you just fill 1 kg of water in a vessel. Okay, 1 kg, a specific mass we are taking, 1 kg, and then it was at 25 degrees Celsius. Okay, you fill from the tap, and then you have to raise its temperature by 1 degree Celsius. To do that, you know how much heat energy you have to give? 4,200 joule. Just imagine 1 kg of water. Okay, you can imagine a 1 liter bottle. 1 liter is nearly equal to 1 kg, right? So that much water, to raise its temperature by 1 degree Celsius, you need to give 4,200 joule, which is quite a large. Same way, every substance has a particular specific heat capacity. So, specific heat capacity of water is 4,200 joule per kg degree Celsius. Okay. Specific heat capacity of copper, okay, will be I think it's 0.42 joule per kg degree Celsius. Okay. So the other way of questioning, either they can ask directly, define specific heat capacity. First is specific heat capacity is heat capacity upon mass. Okay. So that leads me to this formula, Q upon M into del T. And then if they ask you define specific heat capacity, this will be the definition. The specific heat capacity of a substance is the amount of heat energy required to raise the temperature of unit mass of a substance through 1 degree Celsius. Okay. And then this is the formula. Oh, this is not the formula for C. Okay, this is something else actually. So formula is here. C is equal to amount of heat energy upon mass into rise in temperature. Then unit, this part I'll come later, children. This I'll do later. Then SI unit of specific heat capacity is joule per kg per Kelvin. Okay, joule per kg per Kelvin we write doesn't mean that. Okay, so joule per kg into Kelvin basically. Or if I take -1, both will become -1. Okay. Now, see this table. This is the table that gives the specific heat of some of the common substances that we use. And in this table itself, if you see, water is at the maximum. Okay, as I told you, to raise 1 kg of water through 1 degree Celsius, okay, roughly I said 4,200, it's actually exactly it is 4180. For iron, okay, it is 0.42, it was gram, I'm sorry. So if it was in kg, it will be 420 joule per kg degree Celsius. So that's why 483 they are saying. To increase the temperature of 1 kg of iron through 1 degree Celsius or 1 Kelvin, 483 joule of heat energy has to be given. Are you able to see? Okay, so this just gives you an idea. Okay, so if you see roughly, one conclusion you will get, the good conductors, these are the good conductors, no? Copper, iron, zinc and all. The good conductors will have less specific heat capacity, whereas the poor conductors will have more specific heat capacity. Okay, the sense less specific heat capacity means they quickly get heated up. Okay, so okay, so that's the conclusion here. Anyway, so regarding specific heat capacity, the question can be either either like this define, or they can ask you specific heat capacity of copper is 0.4 joule per gram per Kelvin. What do you mean by this? What do you mean by that statement? What will be the answer? The heat energy required to raise the temperature of 1 gram of copper by 1 degree Celsius or 1 Kelvin is 0.4 joules. Hope you got the point, children. If I say specific heat capacity of copper is 0.4 joule per gram Kelvin, मतलब क्या है? What is the meaning of this? What information does it give? It means to raise the temperature of 1 gram of copper by 1 degree Celsius or 1 Kelvin, I need to give 0.4 joules of heat energy. Okay, so if I say, what do you mean by the statement specific heat capacity of water is 4,200 joule per kg degree Celsius? What will be my answer? To raise the temperature of 1 kg of water by 1 degree Celsius, 4,200 joules of heat energy has to be given. To raise the temperature of 1 kg of water through 1 degree Celsius, 4,200 kg is of 4200 joule of heat energy is required. Okay, so this is the meaning of the statement. Okay, so you can just go through the difference between heat capacity and specific heat capacity. So I've covered till this, and I'll be giving few questions for homework. You can write the answers and send it to me. Thank you, children.